In this video, we will be going over the average rate of change of a function. Let's start by looking at an example. So we have a table of values, and the y value is the year between 2005 and 2012, and then C of y is the price of a gallon of gas for each of those corresponding years. So what we want to be able to do is find the average rate of change between any two years. So between 2005 and 2012, well, how would we figure out what the average rate of change is? Well, what we want to do is we want to figure out what's the amount of change that occurred divided by the number of years. So for 2012, we had $3.68, and then in 2005, we had $2.31. And then to figure out how many years that was, we're just going to subtract the years. We end up with $1.37 divided by 7 years, and we end up with about 0.196 cents or $0.196 per year. So what that means is, on average, gas is going up about 20 cents a year. But now let's say we shrink that time window, so between 2005 and 2007. In this case, we're going to say $2.84 minus $2.31, and then 2007 minus 2005. 284 minus 231 is what, 53 cents? So 0.53 divided by 2, that gives us about I should be able to do that in my head, $0.265 per year, or about 27 cents a year. And then lastly, if we shrink it even further to just a 1 year window, we're going to have $2.62 minus $2.31 divided by 2006 minus 2005. And what we get there is a difference of 31 cents over 1 year. So that's about, well, not about, it's 31 cents per year. So what this is demonstrating is something that will be vital in calculus, because what we do in calculus is we shrink this value, the denominator, or the difference in these x values, which we'll talk why that's x value here in a sec. But we shrink the difference there, and so we want to figure out what is the rate of change when we shrink that value down as far as we can. So that is actually something called a derivative. So this format should look pretty familiar to you. It's similar to how the slope of a line works. We do the change in the y's divided by the change in x's. So that's how we can formalize what we're doing here. So the average rate of change, we can say, is the change in output divided by the change in the input. And what we saw on that previous slide here was the output was the cost, the input was the year. So we did the change in the output divided by the change in the input. Another way of thinking about that is the change in the y value divided by the change in the x value, if we're thinking about something graphically. Sometimes this is also described as rise over run. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's just our slope equation. But if we write it with function notation, we're going to say f of x2 minus f of x1 divided by x2 minus x1. And what this means is these x values are just the inputs, and then what we're doing is we're inputting those into into the function and figuring out what those outputs are. So that's kind of a more formal way of thinking about what we were doing with the gasoline prices. Now let's look at the graph of a function. We'll call this g of, I don't know, x here. And so what we want to do is we want to find the rate of change between -1 and 2. All right, so what we're doing is we're inputting these values, so these are inputs into the function g of x. So thinking back to what we just saw, the inputs go in the denominator, so we're going to say 2 minus -1 here. And then what we want to do is we want to say g of 2 minus g of -1. Okay, so again, the numerator is the numerator is the outputs. What happens when we put in the values into the function? The denominator is then what we were actually inputting. So evaluating each of these, g of 2. So we're just going to go here. This is 2, so that function value is 1. G of -1, well at -1, oops, that's 0, -1, we're at 4. Okay, so we're going to say 1 minus 4 divided by 2 minus -1 is 2 plus 1. So we end up with -3 over 3, which is -1. So what does that mean? Well, what that means is between these 2 points on the graph, the average rate of change is -1. And so we can think of this as the slope between these 2 points. So if we draw a line in between these 2 points, that matches up. It's a negative slope. It's going down 1, right 1 each step of the way. So what happens in calculus is we're going to be moving this point, one of these points, to be closer to the other point. So what we're going to do is we're going to move this point, we're going to get closer and closer to make the distance in between smaller and smaller. And so what we want to do is we want to find the rate of change between a very small interval on that function. So yeah, just a little sneak preview for what's coming up ahead in calculus. All right, and then let's wrap up with some algebra, finding these average rates of change algebraically. So here, find the average rate of change for the function f of x equals x squared minus 1 over x on the interval 2 to 4. So what we're going to do is we're going to say f of 4 minus f of 2 divided by 4 minus 2. So why don't you go ahead, pause the video here, and see what you're able to come up with. All right, so we have a little bit of fraction work that we need to do. F of 4, we get 63/4. F of 2, we get 7/2. And then plugging those values in here, and then just simplifying this complex fraction. Get a common denominator at this step. We end up with 49/4 divided by 2, 49 over 4 divided by 2. Remember, when we're dividing fractions, it's the same thing as multiplying by the reciprocal, and that's how we end up 49 over 8. So that is our final answer. As a friendly reminder, I will always say when it's appropriate to use a calculator, this question you should be able to do without a calculator. And that's why we leave the answer as a fraction. We don't need to have a decimal. All right, and then the last example says find the average rate of change of f of x equals x squared minus 5x on the interval x to x plus h. So this one is a little bit more theoretical, and this again is tying into what we'll see in calculus. So suppose I have some function. I don't really know what that function is. It's not this f of x, it's just a random function that I made up just now. And so what this interval is saying is x to x plus h. So pick any x value. How about this x value here? And then what I want to do is I want to move over h units to this point. We're going to call that point x plus h. So in calculus, what we do is we increasingly make that h value h close to 0. So what that means is as h gets closer and closer to 0, this whole value gets smaller and smaller. So that x plus h would be moving left towards the original x value. And that's what we've been saying when we're looking at average rate of change. We want that interval, or one thing we'll be doing is making that interval as small as possible. So that's what this question is leading us into. Now, we just need to remember what we were talking about previously, how we find the average rate of change. Well, the average rate of change is the difference in the outputs divided by the difference of the inputs. So the inputs here are the endpoints of the interval. So we're going to say x plus h minus x. And then for the inputs, well, what I'm doing is I'm plugging in x plus h into the function, and then we're inputting x into the function. So we're going to say f of x plus h minus f of x. Now, looking at the denominator, x plus h minus x, well, the x's are going to cancel. So we end up with is f of x plus h minus f of x divided by h. And this has a special name. If you were paying attention in college algebra, this is called a difference quotient. And this is just a special kind of, not necessarily special, but it's just a more theoretical way of finding the average rate of change. And the reason we do that, again, is because what's happening over here, which we'll be seeing in calculus. So this is a little bit more complex, just because this finding f of x plus h sometimes gives students trouble. So let's do this first, f of x plus h. So what that means is wherever I see x in the function, I'm just going to input x plus h. So we have x squared, but in place of that I'm going to do x plus h squared minus 5 times x plus h. So let's expand this. This is x plus h times x plus h minus, I'm going to distribute the 5x minus 5h. X squared plus, when I multiply this all out and simplify, I get 2xh plus h squared minus 5x minus 5h. So all of this is going to go right here in the difference quotient. F of x is just our original function, and then we divide everything by h. So let's put it all together. A lot of arrows on this page. So x squared plus 2xh plus h squared minus 5x minus 5h. That is all of this expression, f of x plus h. Then I'm going to subtract the function. So it's vital that you use parentheses here because we're subtracting the entire function, and that negative symbol is going to get distributed through into the parentheses. We're going to divide everything by h. Let's see if I can squeeze this all in here. So the only thing to do is distribute this negative symbol, and then some terms will cancel. So I'm just going to rewrite everything. Minus x squared plus 5x divided by h. And so what will happen at this stage is we'll always have two sets of things that are going to cancel. So the x squareds are going to cancel, and negative 5x and 5x. So what we're left with is h squared. This is an h. We're left with h squared plus 2xh minus 5h, all divided by h. And then in the numerator, I can factor out an h. Oops. Factor out h from h squared, so I'm left with h plus 2x minus 5 divided by h. So these h's are going to cancel, and so what we're left with, I'll write it over here, h plus 2x. Let me clean this up a little. H plus 2x minus 5. So that is the value of the difference quotient. So let's just kind of talk briefly about what this even means. Well, back up here, when we're talking about what the h is the difference between the first value in the first endpoint of the interval and the second endpoint of the interval. So h is just that distance. So what's happening is when we're talking about making that interval smaller and smaller, this value is going to get really close to 0. If you've had calculus before, this is the idea of a limit. Don't worry about that right now, though. So essentially what it's saying is the average rate of change is just going to be dependent on what that x value is. So whatever that x value will tell us what the average rate of change is.